Hey everyone, and welcome to the Deep Dive. We are so glad to have you with us, especially all you parents out there. You know, the ones whose kids are learning to code with KOEIGO's STEAM plus Language School programming course at OCSI. We know you must be at least a little curious about what they're up to, maybe even a little intimidated. But that's exactly why we're here, to break it all down for you.
You know, it's incredible to see how kids these days just get computational thinking. These might seem like complicated concepts, but they're actually a lot like how kids already learn and understand the world around them.
Exactly, and that's why we put together this deep dive. It's all about helping you feel more connected to what your kid is going through in this course. We'll be unpacking some of the big ideas, sharing some cool examples, and hopefully having a bit of fun along the way.
Yeah, just think of it like a backstage pass to the world of The Nature of Code by Daniel Schiffman. That's the book they're using for all their coding adventures. And it's not just about, learning to code. It's about learning to think like a programmer.
Okay, so let's take a quick trip back to last week. I know some of your kids were getting the hang of the coding basics, things like loops, incrementing and decrementing, all those little building blocks that make things actually happen in code.
It really is like learning your ABCs before writing a story. All these coding fundamentals, they're the foundation for some seriously complex and creative programs.
And speaking of creative, some students jumped right into simulating a force field, straight out of science fiction. And the secret sauce for that is vectors.
Ah, yes, vectors. A vector is just a way to represent something that has both direction and magnitude. Kind of like an arrow, it points a certain way and has a certain length. Like if you were describing the wind, you wouldn't just say how strong it is, you'd also say which way it's blowing. That's a vector in action.
That's such a great way to put it. And you know, we use vectors for all sorts of things, like the force of a push, how a rocket moves, even the pull of gravity. It's this surprisingly powerful idea that reaches way beyond programming.
Absolutely, and that's what's so cool about The Nature of Code. It takes these abstract programming ideas, and it connects them to real-world stuff that kids are already familiar with.
Exactly, and it makes it so much more engaging for them, and for us too.
You got it.
Okay, so are you ready for this week? Because things get even more interesting. Some students were working on something called a random walk. Imagine like an object moving around, but it's totally based on chance. Like if you flipped a coin to decide which way to go.
Yeah, the random walk. That's a really cool concept. It all ties back to probability and randomness. It might seem kind of chaotic at first, but it's actually a super powerful way to make things in code seem more lifelike.
Like adding a bit of that unpredictability to make the code feel more alive.
Right, exactly.
And while some students were busy with that, others took that force field simulation we talked about, and they leveled it up with something called a map function.
Oh yeah, the map function is really handy. It basically lets programmers translate values from one range to another. So like, let's say you have a number that represents the temperature, but you want to show that temperature as a color on a map. That's where the map function comes in. It takes that temperature number and it maps it to a matching color.
So it's like taking something kind of abstract like a number and making it visual.
Yeah.
Like turning it into a color. That's pretty cool.
Yeah, it's a really neat trick.
You know, one of the things I love about the nature of code is that it's not just about, the code itself. It's about the whole philosophy behind it.
Oh, absolutely. Schiffman really wants you to think like nature, like look for those patterns, experiment with different ideas, and really embrace the beauty of how things emerge.
And get this, he actually self-published the book.
Really?
Yeah. He wanted total creative control, and he wanted to build a community around the book.
That's awesome.
You know what else? The people who backed the book on Kickstarter, they actually got to help make the content better.
Wow, so it was a real collaborative effort.
Yeah, it was. And I think that really speaks to KOEIGO's approach to learning, too.
Definitely. That hands-on, iterative way of learning, it's so important for kids.
Totally agree.
By encouraging them to tinker and play and try things out, they develop some really valuable problem-solving skills that go way beyond just programming.
It's like giving them the tools to not just learn things, but to actually create new things. Now, I know some of the concepts in the book might sound a little intimidating at first, like forces, oscillation, particle systems.
Yeah, those can sound a bit scary.
But trust me, they're all connected to real-world things that your kids already know about.
Right, and that's what Schiffman is so good at. He takes these big, complicated ideas and makes them easy to understand and fun to learn about. Like when he explains that random walk thing, he talks about someone standing on a balance beam and flipping a coin to decide which way to step.
I love that example.
It's such a simple way to get a really abstract idea.
It's all about those aha moments
Mhm.
when something finally clicks. And the really exciting part is that these concepts are used in all kinds of fields: animation, game design,
Hmm.
data visualization, even scientific research.
You got it. They're not just learning to code, they're learning to think creatively and solve problems in a whole new way. The nature of code really lays the groundwork for that. It's not just theoretical. It's a hands-on guide to actually putting these ideas into practice with code.
And it uses processing, which is a great language for beginners because it's so visual.
Yeah, you can see what your code is doing right there on the screen.
Exactly. And that makes it so much more engaging and rewarding.
It's all about making those abstract ideas concrete.
Totally.
Shiffen does a great job of breaking things down into smaller pieces. With clear explanations and helpful examples.
One thing that stood out to me was his discussion of forces. He starts with Newton's laws of motion. I know it might sound a bit dry, but he quickly brings them to life with examples, like simulating gravity and wind resistance and even friction.
Yeah, and those aren't just theoretical examples. They're the foundation for creating realistic and engaging simulations. Like, think about a video game. The way things move and interact, that's all based on forces.
So understanding forces
Yeah.
lets your kids create games where things behave in a way that feels natural.
Exactly.
It's like they're building their own little worlds.
It is.
And that's just one example. The same principles apply to animation and data visualization, and even scientific modeling.
It's pretty amazing to think about where these coding adventures can lead.
Wow, we've covered a lot of ground today. From loops and vectors to force fields and random walks. It might seem like a lot to take in, but all these concepts are connected in really interesting ways. Remember that force field simulation we were talking about? Now imagine combining that with a random walk. You could create a program where particles are drawn to a central point, but they take these unpredictable paths, almost like iron filings dancing around a magnet.
It's a great example of how you can take these seemingly separate ideas and combine them to create something totally unique. That's what the nature of code is all about. Thinking outside the box, experimenting, and just seeing where your curiosity takes you. It's not about memorizing a bunch of code. It's about developing a whole new way of thinking.
It reminds me of something you said earlier about how the book's approach to learning is similar to how kids learn best, through play and experimentation. And those aha moments when a concept finally clicks.
Exactly. And you know, as parents, you can really encourage that spirit of discovery by letting your kids ask questions and tinker with their code and not be afraid to make mistakes. Learning to code isn't about getting everything perfect right away. It's about embracing the process and having fun with it.
It's about nurturing that creative spark
Yeah.
and giving them the tools to become creators, not just consumers of technology. Before we wrap up, I wanted to touch on one more thing that really resonated with me: the author's emphasis on the beauty of emergence.
Ah, yes. Emergence is the idea that really complex behaviors can come from simple rules. Like, think about a flock of birds. Each bird is just following a few basic rules. Stay close to your neighbors, don't bump into each other, fly in the same direction as the flock. But when you put all those simple rules together, you get these incredibly intricate and beautiful patterns.
It's amazing.
It really is.
And the nature of code shows us how to apply that same principle to coding. By setting up some basic rules for how objects interact, we can create simulations that have all these complex, emergent behaviors that sometimes even surprise the person who wrote the code.
It's like a reminder that sometimes the best results come from letting go of a little control and letting the system evolve on its own.
So as you're watching your kids on their coding journey, keep an eye out for those moments of emergence, those unexpected patterns, the surprising behaviors, the pure joy of discovering something new and unexpected. Those are the moments that really capture the magic of coding and the incredible potential of computational thinking.
And remember, you don't have to be a coding expert to appreciate and support their learning just by showing interest, asking questions, and encouraging their exploration. You're playing a huge role in helping them become computational thinkers.
We really hope this deep dive has given you a glimpse into the amazing world your kids are exploring, and maybe even sparked your own curiosity about what code can do.
We're all on this learning journey together, and we're here to support you every step of the way.
Now, before we go, we want to leave you with a little something to think about. Imagine you could use code to simulate any natural phenomenon, anything at all. What would it be, and why? Share your ideas with your kid. You might be surprised by what they come up with.
Until next time, keep exploring, keep creating, and keep having fun.